Hi guys, Shishir here. Welcome you to the module 1 of the week 2 training. Here is what we are going to cover in this training. We are going to learn what is a computer, the basic components of a computer, the basic components which are the motherboard, processor, the RAM and hard drive. We will understand various functionalities around them and various other minor details about them, which are going to be very useful in your understanding of compute, starting from a basic computer which you have, then to a server which you are going to manage in the future, and then going to be a cloud server or a cloud compute instance which you're going to manage. All these things, you need to understand them so that you can understand the meaning of all the things which I just spoke about. So let's get started. Beginning with, what is a computer? We'll begin with a general Google definition. A computer is a general purpose device that can be programmed to carry out a set of arithmetic and logical operations automatically. That's pretty much textbook, no explanation necessary. Now, let's talk about the peripherals of the devices. On the outside, the computer consists of the basic components based on their functions. They can be categorized as input and output devices, like monitor is an output device, you see through it. Printer is an output device, you print through it. CD or a DVD writer is an output device because you write CDs out of it. Keyboard is an input device, mouse is an input device, scanner because you scan the prints and you bring them in your computer is an input device, and CD and DVD reader is an input device. And it's important to understand that printer and scanner usually comes in as a combo pack in a multifunction printer. But again, these are two separate components, so you have to consider that separately as an input or an output device. Overall, you may choose to call it printer and consider it as an output device, but whatever. You need to understand from functionality point of view, they are two separate devices. Same with the CD writer and reader. And of course, then the tower, or as I have heard a lot of people call it, the CPU or the central processing unit. Now that is, I believe, the most correct name for it because it does all the processing, and in fact, it is in all reality the computer. And here onwards, when I say computer, I actually mean the CPU thingy, and don't confuse when I say a computer that I'm talking about the whole keyboard and peripherals and mouse and all those things. They're always referred separately, and in fact, I'm never ever going to talk about these peripheral devices anymore, probably in part of these trainings, except printer. But now onwards, when I say computer, I mean the CPU tower. So, being the CPU, the main important unit of the computer, or the computer actually, let's dissect into CPU and find out what all it is made up of. So, the components of a computer or the CPU. If you usually dissect a CPU, it will look like this, and a more detailed picture without the cabinetry around the real computer looks like this. It primarily consists of below parts. It has a motherboard, the main board. It's also called as planner. You will hear this term more in terms of server because the motherboard of a server is called as a planner. Then you have the RAM, you have processor, you have the hard drive, you have got a display processor. So the display which comes out of the motherboard also needs some kind of a processing to be done. So that component can be a separate display processor, or it could be a built-in processor within the motherboard. And but anyways, it is a display processor. You have the heat sinks and the fans. So these are the heat sinks are the devices which are put on top of the hot units like processor, and then there is a fan which is put on top of them. This is generally to keep them cold so that they don't stop functioning because of the heat. And the temperature of heat sinks etc goes pretty high, like I have seen them going up to 92 degrees Celsius or even more than that. You have a motherboard battery. That battery is required to keep the motherboard alive or to keep its dates and time correct when the computer is completely turned off or it doesn't have a power supply in it. And then you have a lot of PCI and PCI Express slots. So don't worry, I'm not running through all these things. I'm going to explain each one of them in a lot more detail in the coming sections. So we'll begin with the motherboard. And this is how a typical motherboard looks like. Let's begin with the Google definition of a motherboard, or as called planner as well. A motherboard is the main printed circuit board found in general purpose computers and other expandable systems. It holds and allows communication between many of the crucial electronic components of a system, such as the CPU, which is the processor, the memory, and provides connectors for the other peripherals. Like I said, that there are PCI Express cards, and there is display connections, and there is sound connections, and it's talking about all that. And you should also notice here that it is saying that it's a circuit board found in general purpose computers and other expandable systems. So when we say other expandable systems, you have a motherboard within your microwave as well. You have a motherboard in your TV as well. You pretty much have a motherboard in every electronic device which you own. Because motherboard is the component where everything else connects. Motherboard is the foundation of the whole computer. It is how everything else connects to everything else. So, if for example humans are also some kind of a computer, then in our case, our body is the motherboard, connecting everything to everything else, like to the brain, to the heart, to the lungs, and other stuff. Motherboard has dedicated slots for processor, for RAM, ports for hard drive, and other input and output board. You can see in this photograph here, there are multiple things which are shown here: the backup battery, the PCI slots, the ROM, the memory slots, memory or the RAM slots, the CPU, the heatsink, all those things are shown. Apart from the standard stuff like hard drive, processor, RAM, motherboard also provide ports for monitor, USB, and sound, etc. It also has various expansion slots built into it, that is to accommodate external cards to get integrated with the motherboard. These expansion slots are the PCI slots, and we are going to talk about them. PCI or PCI Express cards. So in earlier age, motherboards were very basic, and I'm not talking about 100 years old because these things are pretty recent. I'm talking about when I was a kid. So around year 2000, around 98, motherboards were very basic and with very less functionality, and everything which you needed was added as a PCI Express card on top of it. Back in our days, we used to buy a PCI card for everything from USB ports to dial-up modems to network cards to Wi-Fi cards to graphic cards and to sound cards. Today, the motherboards have a lot more functionality. You pretty much have everything built onto the motherboard. But back in the days, it wasn't like that. When I was a kid, I remember I used to buy all these things, and I put my first dial-up modem inside my PCI Express slot. I put my first network card in my computer. I also put the display cards when the computer gaming started to become a bit more advanced. We bought display cards and we put it in our computer and stuff like that. And all these cards which goes into the computer, they are called as the PCI or the PCI Express card. You may consider a PCI card as a motherboard in itself. As you can see, that's a picture of a PCI card, and you can see that there is, it's definitely a board because it is connecting all the components which it is made up of to each other. And then there is this thing which goes inside the socket, the PCI socket on the motherboard to connect it to your computer's motherboard. Like I said, PCI Express card has its own components. Like graphic cards even used to have their own processor and RAM built into them, just because they wanted to do their job by themselves. Whatever graphics they wanted to produce, they wanted to do it by themselves, and they did not used to bother your computer's processor. They carried their own processor with them, and that's why graphic cards used to be very, very, very expensive as well. In fact, even today, graphic cards are pretty expensive. And such PCI cards, they just plug into your motherboard and provide the additional functionality which you need. Nowadays, a basic motherboard has all the functionalities built into it, like network, USB, external SATA, sound card. Even there are built-in graphic cards which are better than the external ones which we used to buy back then. But still, if you want to upgrade your experience, then you need to buy a a dedicated display card or a dedicated sound card or any other sort of the card, because these cards are just the ports on which you see outside. Like usually when you look from the outside of the computer, you will see these blue ports showing up. But these are not just the ports. They actually have a dedicated processor. They have a specific driver to perform the function, and they are in themselves very powerful to deliver some kind of a dedicated experience. So depending on what your requirements are, you may choose to buy a PCI or a PCI Express card for your computer. However, like I said, nowadays motherboards are pretty advanced and they have all the required functionalities pre-built into them. Because we are talking about the motherboard, I wanted to clarify another confusion, which is between the chipset and the motherboard. So, chipset is kind of the layout or the design or the components which are present in a motherboard. In layman terms, I can say that the design which an architect made for a house, specifying all the details and planning, etc. That is the chipset. Whereas the motherboard itself is just the built up house based on that initial plan. It takes a lot of brain to design the chipset. Whereas creating the motherboard is just basically a manufacturing operation. Once you have all the plans, you feed all the plans to some kind of a machine or a system, and it basically print out the board for you. And then depending on the kind of motherboard which you are selling, you will put some kind of a sound card on it, you will put some kind of a processing power in it, and not the actual processor but the processor for the sound card or the processor for the display if you want to provide them a dedicated stuff. But the chipset is the actual design which on which a motherboard is made of. And a chipset is very expensive in terms of, like, you always buy a motherboard, but for a motherboard manufacturer, getting the chipset design and the licensing is more expensive than actually just creating a motherboard. There are very few chipset manufacturers, and out of these as well, mostly Intel and AMD occupy the market share. So you can see that there are a few chipset manufacturers, and again, this is a Google screenshot from AMD to Intel to Nvidia, from SIS, from VIA, from Serverworks. But quite honestly speaking, you would see that most of the motherboards which are out there in market are made upon Intel chipset, and then there are some certain which are made upon AMD chipset, and rest all of them. I think Intel should occupy around 50 to 60% of the market. AMD should have around another 30% market, and rest all of them together will constitute for around 10% of market. I don't have the figures or numbers for it, but what I'm trying to convey is that most of the motherboard are based on Intel chipset. And then there are so many motherboard manufacturers in the market. So you can see all these companies, they are making motherboard. And this is still a subset of the list. There is a lot more motherboard manufacturers which are available. And you sometimes buy an Intel motherboard. So that's a motherboard which is based on an Intel chipset and is manufactured by Intel. But in other cases, you may want to buy a cheaper motherboard and you go for a BioStar motherboard based on an Intel chipset. Once again, it is the same planning done by the Intel, but the motherboard is manufactured by BioStar. So same with Gigabit or MSI or Asus. All these companies just make the motherboard based on the designs which are provided or the chipset information which is provided by Intel. Let's talk about the next most interesting topic, the processor. Remember the name CPU which we gave to the tower? Technically, processor is the actual CPU or the central processing unit. Hence, usually I'm not very comfortable calling the tower CPU. Let's once again begin with the Google definition of a processor. A central processing unit, also called a central processor or main processor, is the electronic circuitry within the computer that executes the instruction that make up for computer program. The CPU performs the basic arithmetic logic controlling and input-output operations specified by the instructions in the program. So, in easy definitions, processing or the CPU is the brain to which you feed the raw information and it provides you the calculated and computed result of that information. There is definitely a more dense definition to that, but I would not go into the details of those definitions because I don't see a reason to get into them. But feel free, if you want to really put your brain inside what is a CPU, you can do a PhD in CPU itself. So moving on, In easiest terms, a processor is the brain of the computer. Intel launched the first CPU in 1971. Before this, there were no microprocessors. There were more of the vacuum tubes. So on the right here, what you see is a photo of a processor, how it used to be before. So that's like a lot of vacuum tubes which are there. I don't know if you can read, I can see IBM written on those vacuum tubes as well. But on the left hand side, this is the 1971 first microprocessor which Intel made. Intel 4004 is a 4-bit central processing unit released by Intel in 1971. It was the first microprocessor and the first in long line of Intel CPUs. So this is the difference. So I am pretty certain this Intel 4004 chip which you are seeing there is a lot more powerful than that vacuum tubes which you are seeing on the right hand side. Now there are primarily two manufacturers for processor which include Intel and AMD. However, the original design of a CPU came from Schatz engineer from Japan, and there is also some role of Motorola as well in the processors. But as we know today, mostly it is Intel and AMD that we hear of as processor manufacturer. And these are the various generations of Intel and AMD processors which have been. So Core 2 Duo in 2006, i7, i7 again, i7 Haswell, i7 Sandy Bridge, then we have got i7 Skylake, and then we got i7 Ice Lake in 2019, which is the 10th generation, and now we have i9 processors. So that's how Intel is going. And for the AMD, we have got AMD Athlon, AMD Sempron, then the Ryzen is the latest one, which I keep hearing about. There is Ryzen 5 and Ryzen 7 series. And yeah, but like I said, Intel is the most famous one, and most computing devices, including your phones, etc., comes with Intel processor inside it. Now, I want to make it a bit interesting, and you understand the basic manufacturer, you understand that there are two processor companies, mainly AMD and Intel, but I want to go into the architecture of processor a bit to give you understanding of socket, cores, thread, and the frequency or the processing frequency of a processor. This topic is the most important one in terms of understanding processor. So basically how you differentiate between processor is based on its socket, core and threads. So just to give you a basic understanding, what you are seeing in this photo here are the two processors. Or rather I should say the bottom layer here, this is like a socket. On top of it, this is like a processor, and then within that processor there are two cores. Now this is another socket, this is a processor, and these are the two cores within that processor. Let's take a deep dive into it. Socket is the physical design of the processor connecting pins. So on your motherboard you would see something like this. This is what the socket is. So the processor gets connected to the motherboard. Now the connector on the board and the connection on the CPU should match. So a board comes with a specific kind of a design. So when you buy a motherboard, you get to know or you read its specification and you figure out what kind of a socket is there in that motherboard. Is it LGA 10, LGA 11? There are more kind of sockets. I don't remember the name of each one of them. But you need to buy a CPU which matches that design definition. So if this is a LGA 10 socket which you have, you need to buy a LGA 10 CPU. Whether you buy it from Intel or whether you buy it from AMD, it doesn't matter, but it needs to be LGA. There could be more engineering behind the socket, but that's the overview of it, and you would hardly ever need to know much more of it in your career. But it is good to understand that what is a socket and how a processor fits into it. And I would really like for you to open your computer and maybe pull out your processor. If it's a motherboard, if it's a laptop, it's quite possible that the CPU is embedded, so you can't take it out. Like when I say embedded, it's basically soldered into the motherboard, so you can't take it out. But if you have a desktop computer, then most likely you can take out your CPU, you can have a look at your socket, and you can put it back in. So the physical shape of all the processors may look the same to you from outside, but the arrangement of pins can change the socket type. So you can see that these are various socket type. There is 68 pin PLCC, there is socket 486, there is socket 7, socket 5. Then on the bottom you can say LGA 1366, LGA 771. These are some latest one, LGA 775. All these are different socket types. Once again, you hardly ever have to think about them because as an engineer of IT infrastructure, you will be mostly working on the software side of the computing infrastructure, but it's good that you understand these fundamentals about the processor and their socket. Now, most machines have a single socket for CPU. So, all the computers that you will see, mostly they will have a single socket for CPU. But then there are certain servers which are available, and now even certain computers or the PCs which have a capability to have more than one physical CPU embedded in them. So, you can buy two CPUs and you can put two CPUs in your motherboard, and that gives you ability to have dual processing power or a lot more processing power, because I'm going to tell you more about cores in the coming sections, and the cores is already dual or quadruple power which is available, but having more processors, you can put one processor here, one processor here, that definitely makes your computer a lot more powerful. It's more common in servers, but yeah, I have seen that certain client motherboards are also coming up where you can have dual processors. There was a time processor used to be a single core, and that was good because you buy one processor and you get one processor. But now life is a bit more complicated. One physical processor can have multiple virtual processor within it. They're called as cores. Each core within a physical processor is kind of an independent processor on its own. We got dual cores, then we got quad cores, then we got octa cores, and I'm sure we are headed for a lot more. And you can see in these images on the left hand side, you have an Intel image. Basically, it's a physical single processor, and inside that they are trying to show that there are two cores. And then on the right hand side, it's a logical diagram of a processor which is showing core 0, core 1, core 2, core 3. So it's a quad core processor. There are multiple cores which are coming up. After the cores, there is the threads and the frequency. So how you define a processor is basically its name, its number of cores, its number of threads, and its number of frequency, or what's its frequency. That's how you can actually identify what is the speed of a processor. Now, threads and frequency is a bit typical. So let me try to give you an example. I'll give you an analogy. Let's assume that we have a factory in which we put raw material at one end and the processed good come out of the other hand. How fast the processing happens depend on the number of men which are working inside this factory. And further, how fast the work is dependent on how many hands each man has. And last but the most important one, how fast each man can move his hand. So once again, there is a factory, you put goods at one end and processed goods come out of the other end. How fast this process is going to happen depend how many men are inside the factory, working inside the factory, how many hands each man have to work, and then how fast each man can move his hands. So that's the time which, or that's what is going to define how fast the processing is going to happen. So in this analogy, the factory actually represents the CPU. The number of men working inside the factory represents the core. The hand of each man is the threads. So usually every core comes with two thread only. I don't think there is a lot of threads, more threads available than that, but mostly each core has two threads. So this example is perfect. So each man is a core. His two hands are the two threads which are there in that CPU, and the speed at which these men can move their hands is the frequency of the processor. Hope it makes sense to you. Now, theoretically speaking, it's a delicate balance between the number of cores, threads, and frequency. A delicate balance in terms of what's going to be performance of a CPU. Because if you have a processor where the frequency is 3.0 gigahertz and it has only one core, then the output is probably 3. 3. Or there could be another processor where the frequency is 1.0 gigahertz, and the number of cores, like that's the number of men inside, are 2, then the output will be only 2. So despite of the fact that the second processor has lesser cores, or the first processor, I'm sorry about that, despite of the fact that the first processor has lesser cores, because it is acting fast, it can give you a better output. Whereas in the second processor, number of cores are more, but these are lazy mans. Number of cores is equal to men. These are lazy mans. They are working at a frequency of 1. The output which you will get is only 2. I hope you understand the relationship. Now, in reality, this really doesn't happen. But sometimes, especially when buying a processor, you will end up in a dilemma with the frequency of a low processor will be higher, but the cores on the higher end processor would be more. There are various websites which compares the performance of a processor, and it's a more complicated than how I have explained above. There is also a software engineering side of how the processor are getting smarter and smarter. So you can believe that, fine, I gave you all the numbers, but what about the people inside the factory? They are getting smarter. So maybe the smarter people do less work, but still they are able to achieve more efficiency or more output. So that's what we are talking about. The generations of the processor, they have a software engineering built into them as well, and they are doing more and more work. So a newer processor core may not have to wave his hand as fast as the old core, but will be able to do the same job, maybe even better. Okay, now that's the basic understanding. So once again, the factory is the processor, the number of men inside the factory are the core, the two hand of each man is the number of thread, and how fast they move the two hands is the frequency. And overall, this tells you how good a processor is. My next favorite topic, RAM, or the random access memory. Is a random access memory. People also call it as the temporary memory, as it is flash once the PC is rebooted, or even when the current program is closed off the PC. Let's look at a Google definition. Random access memory is a form of computer memory that can be read and changed in any order, typically used to store working data and machine code. A random access memory device allows data items to be read or written in almost the same amount of time, irrespective of physical location of data inside the memory. So this, what the last line, which is about how fast it can read and write data, that's because the read and write operations, there is no disk inside a random access memory. This is all chip-based memory. So despite of the fact where physically the data is located on these random access memory, it can still read it very fast. So this comparison is actually coming in comparison to a physical SATA hard drive. And when we go into the hard drive section of the rather when we go to the hard drive topic, you will understand the meaning of this thing a lot more. But basically, as of now, let's take this fact that wherever the data is stored on this chip, it can be accessed at the same amount of speed, and there is no physical movement required which can slow down the RAM. That's a good thing about it. Now there are various kind of RAMs available today, being used in different kind of machines, like from TVs to computers to phone, but their purpose mostly is the same. And we won't go into detail of each one of them separately because it is not required for our purpose of teaching. So there is like dynamic RAM, there is SD RAM, there is synchronous RAM, there is DDR RAM, there is graphic DDR RAM, and there are SD RAMs, and there are flash memory. So there are various kind of RAMs. Once again, if you want to go into the details of RAM, you can do a PhD in itself. But for the purpose of this training, it's not too much required to know about every RAM. Rather, it's more important to know what a RAM is. So just to explain RAM, if we go back to our analogy of the factory, which I gave to explain the processor cores and frequency, RAM is the work area which is available to each worker to perform the task. So more the space is available, easier and faster will it be for each worker to finish their task. Imagine you are in a cramped room and hundreds of people are standing beside each other, and you all are trying to do your job in a limited amount of space. How productive can you be? Whereas you are, as compared to that, you're sitting in a huge room, you have a huge work table in front of you, and you have all the flexibility available to do your work, and you will be able to do the work a lot faster. This is the reason that we give this table as the photograph for RAM. So this is the table. This is how you need to consider the RAM. Everything from the warehouse is brought onto this table, and you can act upon, or you can do your job, and you have a lot of space available. More the space available to you, more easily and functionally you can do your work instead of being crammed into a corner, which is the lack of the RAM. Hard drive. Once again, going back to my analogy of factory, the hard drive is the warehouse where you keep the raw material and where you save your processed material. The amount of time the warehouse takes to input and output the material can greatly affect the speed of your computer. In fact, almost 7 to 8 years ago, we started to see a situation on the computers where the RAM and processor were getting bottled because of the hard drive performance. The first hard disk was introduced in 1956 by IBM. Okay, so just to explain a bit more about this, we are saying that the hard drive is the warehouse where you keep all your raw material, and then where you also store your processed material or your output. Now, just imagine that you are a factory worker, which is your processor, if I may say, and you are standing on your table, which is your RAM, where you have to work, and the amount of time it's going to take to get the raw material from the factory or from the warehouse, or which is the hard drive, to your table, that's going to degrade your performance. You might be standing there doing nothing, just waiting for the raw material to come to you so that you can do your job, and the hard drive is very busy and it's unable to give the raw material to everybody because it is the start of the shift, and over 300 employees need their raw material, and it is taking its own sweet time delivering the raw material to everybody. So that's what I'm saying, that earlier processor and RAMs were not that powerful, but now in last 7 to 8 years there have been a lot of development in terms of processors and RAMs, and the hard drives actually lagged behind a bit. And we have started to see this from past 5, 6, 7 years, that on a lot of computers the processor and RAM are top notch because people know about them. People buy the processor and RAM, or the computers which has the best processor and best RAM, but they don't think about the hard drive. And there are so many computers where we have just changed the hard drive to a better hard drive. We are going to talk about them just in the next section, to make the performance a lot faster, because processor and RAM were sitting idle. They were not able to get the data from the hard drive to process or to do the job. Let's talk about the type of hard drive, and then you will understand it a bit more. There are two general types of hard drive. One is the HDD, or the hard disk drive, which uses one or more rotating disk and rely on magnetic storage. The other one is a solid state drive, SSD, which have no moving mechanical part but uses flash memory, kind of found in USB flash drives, the flash drives which you have, or you can say in kind of RAM. So this is the SATA drive, or the HDD. Rotating disk drive, HDD, like PATA or SATA, were the first to be introduced, and they are still in use. They work like an old gramophone, which you might know of. The HDD is built up using multiple disks inside the casing. There is a head or a reader on both sides of the disk. You can see there is a reader on both sides of the disk. The information is stored in various sectors on the disk, and the disk rotates very fast, and the head reaches the sector where the information is stored, and it reads and provides back to the client. Just imagine the work which I am talking about. These disks moving on the spindle is the central axis, and multiple disks depending on the capacity of your hard drive. Multiple disks are there, and then you have the head, both side of the disk, and then you have these arms on both side of the disk, and the data is divided into sectors. We are going to read about that in future, in the next section. But basically, the data can be stored anywhere on this disk, and just to read that information, the disk is moving fast and fast and fast, and this head is going to every corner. Just think about the physical engineering which this disk and the hard drive have to do to retrieve the data. And going back to my example of factory, just imagine there are 300 workers who are requesting the data, or 300 processors or processes which are requesting the data to do their job, and this hard drive is struggling to get every bit of information from every corner of the hard drive. That's what makes it slow. These mechanical ways of reading and writing the data itself makes such hard drive very slow, and there is so much of energy wastage in form of heat because of all the friction created by the disk movement. And in fact, such hard drives are very prone to failure as well. After all, there is a very delicate arrangement of multiple disks and header running on around the same axis or the spindle inside each hard drive you see. When Mel handles these complex arrangement breaks and the hard drive stop rotating and working all together. And guys, I have seen this practically so many times. Like I come from the olden days where we used to have all kind of hard drives, and we used to take out our computer hard drive and give it to our friends and used to carry in our school bags and stuff like that. And there were a lot of cases where this hard drive actually got bad. Like you just gave it to a friend and it didn't work on his computer just because either me or him, we would have handled the hard drive, or we might have just put our bag a little strong on the table or something. Basically, these are very complicated stuff. Like these are multiple disks, and they are in a very delicate arrangement where if anything moves a little bit, the disks start touching each other, or they start leaning over the head, and suddenly this stops working. And this has happened quite often. There is another problem which happens with HDD, which is known as fragmentation. Like I told you, that data is stored in sectors on the hard drive. So you can assume them as small blocks which can contain information. Look at that disk. There are multiple tracks, and then these lines are there, and then within every track there is a sector. Now when a hard drive is empty, all the information is written sequentially. So when you have a new file or new data and your hard drive is empty, you go ahead and write the information. It's going to be written in the subsequent or sequential sectors. But when the hard drive starts to fill up, the information gets written on distant sector. And then to read the single file, the head must rotate to different area of a disk, of a single disk, or multiple disks, because every hard drive contains multiple of such disks. And when this happens, when the data gets fragmented between different sectors and different disks and different places, this slows down the computer, because the head have to go to multiple locations just to retrieve a single file. It's not that the file gets corrupted or there is a problem with this approach, but the physical work required to do this job is way too much. And to fix this problem, what we do sometimes is a process called as defragmentation. It's a cool name given to the boring task of rearranging your closet. So basically, over the time, it happens, you write some data, you delete some data, you write some data, you delete some data. Over the time, the data gets scattered across various sectors. And when you are trying to write a new file, it will find one sector in disk 1, and it may find another sector in disk 5. And when you have to read the data, you get the whole information. So there are two different reader heads which are going to two different disks, which are going to two different sectors to retrieve one file. And that's becoming slow. So over the time, this happens a lot. And to fix this problem, what we do is we call it as defragmentation. So defragmentation is a procedure where your computer goes back and rearrange the whole closet. So all the files which are together, they come in sectors next to each other, and the files basically, yeah. So the scattered approach gets broken down and become more sequential. This is a very boring task, and depending on the size of the hard drive, it takes a lot of time. So back in the days when I used to run defragmentation on my computers, it used to take overnight or even few days for the defragmentation to complete, and your computer become awfully slow. And you also have to remember that you need to have enough space, enough free space on your computer to defragment the drive, because it is simply your closet. And if you have to rearrange it, you have to bring the stuff out, put it on a temporary place, then rearrange the stuff and put the stuff back when you have created a space for it. So in order to defragment any disk, you need to have at least 25% free space on that disk. Otherwise, the defragmentation will also not run. It needs to have free space or temporary space to put the stuff around. Solution to all the problems: solid state drives. If you look at the photographs below, it's pretty much like your RAM. It is chip based memory. SSD are relatively new concept. They have become common in past 8 years or so. They are still quite expensive as compared to HDD drives. As a ballpark figure, it's inefficient to buy anything less than 1 terabyte of hard drive because even below this capacity, they will price the same. They have become so common. And on the other hand, most common size for SSDs even today is 256 GB, or on rich people's computer I see 512 GB or something, because they are highly expensive. SSD is an electronic device with chip-based memory. It doesn't have any moving parts, any head, or any disk. It is less prone to failure, and also there is no fragmentation that occur on SSD. Or rather, I should say the fragmentation does occur on SSD, but it doesn't impact the performance because there are no moving parts and the head do not literally have to go to 20 different locations to retrieve the information. All the information is stored electronically and it is just retrieved within a second. So this is why the solid state drives are very fast. And I was telling you before a couple of topics or section, I don't know, but I just mentioned that there was a time when the processor and the RAM on the computers were really good, but because people were still having the slow hard drives on their computer used to become very slow. And I have replaced HDD drives with SSD drives on an 8-year-old computer, and believe me, they become lightning fast, way ahead. So anything can cause a slowness from processor to RAM to hard drive. And now in most of the cases, I see people have good processor, good RAM, but they are underutilized because they have a bad hard drive. Hard drive formatting. This is an interesting topic, and this is getting more into the software side of hard drives rather than the hardware sides which we have been discussing so far. Let us begin by understanding how data is written on hard drives. We all know that at its core, a computer can only understand binary information. Same on hard drive. The data is eventually written as a collection of ones and zeros. There is nothing else on the hard drive. Now, of course, it's a huge area, so it needs to be clearly demarcated to ensure everything falls in its place. That's what formatting does. When you format a drive, a couple of things happen. You create logical sectors known as clusters on the hard drive. Size of each sector is something which you specify when you begin formatting a disk. Each sector can be of 4 KB to 8 KB or more. There is advantages of making the sector big or small. So with this sector, we are talking about the small sections which are getting created on the hard drive. I showed you before as well. Yeah. So this is what we are talking about. Now the advantage of the sizes of sector. Bigger or lesser sector we have on the drive, faster will be the speed of reading the data. So you have broken down a room into only 8 sections. It is quite easy for you to locate the data from that room because every section has got one piece of data. Whereas if you break the room down in 500 sections and every section has a bit of a data, and if I ask you to retrieve the data, you're going to take a lot more time to retrieve the data. So bigger the sector or lesser the sector on the drive, the faster will be the speed of the drive. Disadvantage. So if you're on a Windows PC, you right click on a file and open its properties. You will see it has two sizes of the file, the size on the disk and the real size. Let me show you. So here, as you can see, this is the property of a file. The size on the disk is 108 KB and the size on the disk is 112 KB. Now why is that? If we have 4 KB sectors and there is a 6 KB file, its size will be 6 KB, but the size on the disk will be 8 KB because it occupied 2 sectors to store the file, and it's not going to share its sector with another file. So the 2 KB gets wasted. Now if you make 12 KB sector and store a 2 KB file on it, it will occupy one full sector for one file. So it will take away 12 KB space of your drive. Basically, your hard drive capacity will get reduced. So if there is a 2 KB file on a 12 KB sector, the size of the file will be 2 KB, but the size on the disk will be 12 KB. So you kind of waste a lot of space. So you really have to decide on the sector size very carefully, but usually people keep it to 4 KB. Now, formatting the hard drive. It also consists of partition table. An index or a partition table is created with the information about what's there in each sector. So if you have divided your hard drive into so many sectors and you're putting information in each sector, and if you want to retrieve that information, you need to have some kind of an index to refer to what information is where. So you need to consider this index like an index of a book, which tells you which page has what information. Remember, the header in an HDD, it basically must look at this index to find in which sector it will find the information which it is trying to look for. It can't just go into every sector on your hard drive to look for a particular information. It has to specifically know in which sector the data is, in which disk, what sector the data is, so that it can go there and read the information from there. And that's what the partition table provides. Now, you also do a quick format of a full format. Generally, in quick format, just this partition table is cleared. The actual data is left on the disk as is. So basically, the index shows that all the clusters are empty. And the data, and once you see everything is empty, the head believes there is no data on the disk, the computer believes there is no data on the disk. And as you start writing new data, the data on the disk starts getting overwritten. Once again, I would like to tell you that data is written in the format of zeros and ones, binary. So there is nothing else but zeros and ones. So when you overwrite the data, once again, you write zeros and ones on top of that. But what we need to understand, a quick format basically deletes the partition table and it just leaves the data on the disk as is. And when you start writing new data on the computer, the old data starts getting overwritten. However, in full format, the data is deleted from each cluster before rebuilding the partition table. Hence, when a hard drive fails, the data recovery companies are still able to get the data because full format hasn't happened on the drive. However, after the full format, it's nearly impossible to recover the data. So I don't know if you have noticed this thing ever in your life, but when a hard drive of your computer fails, you can go out to a lot of data recovery companies, and these recovery companies will run operations on your hard drive and they can recover the data. And the reason why they are able to recover the data is because they have certain tools with which they are able to rebuild your partition table to identify the data, or just copy over or clone over your hard drive and then identify the data in it. But whereas if you do a low level format or a full format on a hard drive, then the actual data get deleted from the hard drive, and in those cases these recovery companies may not be able to recover the data. Another interesting topic to understand about is the FAT and NTFS file system of a hard drive, or the file allocation table versus the new technology file system. So what is FAT? Microsoft created file allocation table file system in 1977, and it is the simplest file system supported by Windows NT. It is the older of the two file systems and therefore isn't as efficient or as advanced. However, it does offer more compatibility with other operating systems and removable storage devices. The FAT is used to describe the allocation status of the clusters, the basic unit of logical storage, the clusters which we discussed just the section before, in a file system, as well as the link relationship between each. It acts as a table of content. It's the partition table now we are talking about. It's act as a table of content for the operating system, indicating where the directories and files are stored on the disk. A FAT is often most used in removable storage devices such as digital cameras, smart TVs, and other portable devices. So a FAT file system, however, you're going to learn that NTFS has replaced it mostly in terms of Windows computer, but a FAT file system is still being used in a lot of digital cameras and smart TVs and other portable devices. The file allocation table is a critical part of the FAT file system. If a FAT is damaged or lost, the data on the hard drive become unreadable. There are several limitations to using FAT32 file system. So these are the limitation of the old age FAT32. It only supports up to 4 GB file sizes. So a single file size cannot be more than 4 GB. If it is more than 4 GB, it cannot be copied on a partition which is formatted with a FAT file system. Volumes can be up to 2 TB. So the hard drive, the actual C drive or the D drive which you create on your computer, they cannot be more than 2 terabytes in size. FAT32 isn't a journaling file system, which means a corruption can happen more easily. So it has less fault tolerance to the corruption of the data. And FAT32 doesn't support file permission, which is a big drawback. And that's why it is not used in Windows computer anymore. It doesn't support file permissions. So what's the alternative? The alternative is NTFS. Microsoft created new technology file system back in 1993, and it is now the most widely used file system in Windows. It was introduced as a replacement for FAT file system and designed to improve upon FAT by increasing performance, reliability, and disk space. NTFS support very large files, whereas FAT only supports file size up to 4 GB. It supports file permissions and encryption, which is not supported by FAT. Automatically restores consistency by using log volume and checkpoint information. So the journaling, which wasn't available in the FAT, is here. So it is more consistent and it has less chances of corruption. File compression when using running out of disk space. So you can compress the size of a file if you're running out of disk space, and you can establish disk quota limiting the space users can use. So NTFS has a lot of advancements. Let's do a quick comparison between FAT and NTFS. FAT is the more simple file system of the two, but NTFS offers different enhancement and offers increased security. Choosing the right operating system for the files depends on your needs. Fault tolerance. NTFS automatically repair files and folders in case of power failure or errors. FAT32 maintains 2 different copies of the FAT in case of damage. So both of them have some automatic recovery mechanism. If you read this line once again, the FAT32 maintains 2 different copies of FAT. The second FAT is the file allocation table. It is the index that we are talking about. So FAT32 system maintains dual copy of the index in case it has to recover that, because it is the main component from where the data, or it can identify what data is where. In terms of security, FAT32 only offers shared level permissions, while NTFS allow you to set specific permissions on local files and folders. We're going to talk about the permissions in future, but this is the difference, that FAT32 you don't have a folder level or a file level permission, whereas NTFS allows you to have a folder and file level permission. Compression. FAT32 does not offer any compression. We discussed just now that if you're running out of space, you can compress a file. NTFS allow for individual compression of files and folders so that you don't slow down the system. Compatibility. NTFS is compatible with operating system back to Windows XP, and that's mostly Windows. For Mac OS, however, NTFS system can be only read by Mac, while FAT32 system can be both read and written by Mac OS. So interesting issue happened with me when I first bought a Mac, and I had a drive, and it was NTFS formatted from my Windows PC. I put the drive on on my Mac. I connected it. I was able to copy the data from it, but when I was trying to paste the data back on the NTFS formatted flash drive, I was not able to do that. When I had to do something, I don't know, I was just making some software or extracting some software updates for my computer, for my car computer, and this NTFS and FAT actually created a lot of issue for me back then. And the basic reason was that my Windows computer was able to do stuff on NTFS, whereas my Mac computer was having troubles with NTFS, and so was my car was having trouble with the NTFS. So I had to reformat the drive with FAT32 so that it becomes compatible on Windows, becomes compatible on Mac, and also on my car. So FAT32 is more acceptable by most of the operating systems or the interfaces. The biggest disadvantage of using NTFS file system is the compatibility. Many removable devices such as Android smartphones don't support NTFS, while Mac OS X can read support for NTFS drive, but it cannot write on NTFS drive without third-party softwares. Some media devices, including smart TVs, media player, printers, don't support NTFS. My car also didn't support it. NTFS file system are only compatible with Windows 2000 and later version of Windows. So Windows 2000 and later is pretty much all the operating system that you are going to deal with nowadays. When it comes to removable devices, it is safer to use FAT32 so that they can be used with almost any device. So don't waste your time like myself, where you formatted a drive with NTFS and then face so many issues. It's easier to format the drive with FAT32, which is acceptable with most of the devices, and they will be able to access the data for you. All right. So now let's talk about the folder and share level permissions. We just spoke about that the FAT do not allow you to give file level and folder level permission. You can only do share level permission, whereas NTFS lets you give file and folder level permissions. So NTFS allows us to create permission on folder level. So every folder which is created on a PC can have security permission to define which user can read it, write into it, or delete it or modify it. On a Windows XP PC onwards, you can go to the properties of any folder or file and you will find security tab there. You can add the users from your PC or your Active Directory domain. We are going to discuss the Active Directory domain in future, but for now, just read it as a line. You can add users from your PC and your Active Directory domain and provide them with relevant permissions on the files and folders. So if you can read in this screenshot below, you can see that there is a full control which is allowed, there is a modify which is allowed, there is a read and execute which is allowed, the list folder contents is allowed, the read and write is allowed. Similarly, you can deny all these permissions. You can go to, if you are on a Windows computer, just go to any folder, open the properties, and you will be able to see these options there. Share levels permission, we are going to specifically talk about them. Folders can be accessed by other machines over the network as well. So a lot of cases you will be accessing, or people will be accessing, a folder which is on your computer from another location, like in file server cases or some other cases which we will discuss and you will learn over the course of your work. So folders can be accessed by other machines over the network as well. Now for them to be available on the network, they need to be first shared. And upon sharing them, you can also apply share level permissions on them to define who can or cannot access these folders. Once again, go to the properties of your folder, and then you will see there's a sharing tab. Go to sharing and select the option to share this folder. It will give you a name of the folder with which you can share it, and then you have the permissions button which will pull up this permission dialog box, and you can give people share level permissions here. As a rule of thumb, we recommend we provide everyone full control at the sharing level permission and control any security on NTFS level only. This eases your troubleshooting and the security is same. So what we are trying to say here is that if you have to share a folder and if you want to restrict the number of people who can access this folder, we still recommend that you go to the share level permission and there you say everyone, select it, and then give them full control. And then into the NTFS or the security tab of that folder, there you specify who can and cannot access the folder, because this way your troubleshooting will be a lot easier. You should understand about security in Microsoft ecosystem that always the most restrictive permission gets applied, which in easiest terms means that if you are allowed by 20 different permissions and at one level you have a deny permission, then eventually you will have a deny permission and there is no way around it. So let's say that you are part of 20 different groups which gives you access to some data or some folder, and then there is one particular group where because of which you don't have the rights, or which basically gives you a deny permission on a particular resource, a folder or a file, then the end result will be that you will not be able to access it. It doesn't matter how many groups or places you have been allowed to access the data from. It only matters that there is one person or a one group which denies you from accessing the data and you will not be able to access it. And that's why we say that most restrictive permission wins in Microsoft ecosystem, and that is why on share level we allow everybody, and on NTFS level we restrict or do the more secure permissions so that people can only access what they have rights to. All right, so Here are your action items for this module. This is the end of the module. I would like you to open your computer if you have a desktop or a laptop or whatever and identify the various components in it. I would like you to get familiarized with the hard drive and with the processor and with the RAM and stuff, etc. And try to maybe remove them, put them back in your computer. Once again, be careful about it. I'm not guaranteeing that we'll be fixing your computer or whatever. You have to be careful about not breaking it. But yeah, it will be good if you get a good hang of it, understand the various components, see how the hard drive is connected to the motherboard, see how the processors are connected to the motherboard. If you have a laptop, the information will be a little more tight knit because everything will be embedded on the laptop motherboard, and it is far less likely that you'll be able to do anything. However, you should be able to pull out the RAM or put the RAM back in. That's the easy one. You might even be able to, yes, you will be able to take out the hard drive as well in a laptop, but the processor is embedded on the motherboard, most likely. There is few laptops where processor can be removed, but they are very rare and they are pretty expensive, so I don't know if you have them. The second thing which I would like you to do is format the hard disk drive on a computer, like just put a USB, look at the options which are available, look at the sector size which is available for you to format it with, look at the FAT and NTFS options which are available, format it with FAT or NTFS, define the cluster size, etc. Refer to a file size on your PC, look for the disk size on disk and look for the size. This will give you the perspective about what I was talking about, how many sectors it occupies. And then create a folder on your desktop and share it with the appropriate NTFS share permissions, etc. All right. Before I leave you, I'm going to quickly show you some of the things which we discussed about the share permission and the NTFS permission, etc. on a Windows machine. So what I'm going to do is I'm going to RDP into, actually I've already RDP into one of my server. This is running on Windows Azure, like an infrastructure as service, but we'll talk about it later, some part of this training. But for now, I just want to tell you that this is a Windows 2016 server, and I'll just tell you what it is. WinVer, and yeah, it's a Windows Server 2016 and it's running on Azure right now. I'll just quickly create a folder here and I'll show you the share level and the NTFS level permission. FYI, I give it a name share. In fact, I'll make it share 1.2 just to tell you that the word share has no meaning. It's just the name of the folder. And then I go to the properties of this folder and here is the sharing tab. And it currently says that it's not shared. I'll click on the advanced sharing here and I'll say share the folder. I have an option to share it with the current folder name, that's the default option, or I can go ahead and share this folder with a new name, Shashar, and I say apply. And this folder got shared with my name. I can also share this folder with another name. So let's say share it with share, so you can share it with multiple names. And now you can say that the same folder is shared with two names. And as far as the permission is concerned, I will go ahead and give everyone full control at this level. Like I said, that the most restrictive permission apply. So at share level, I'm going to give everybody full control. And then in the security, I can go ahead and I can give whatever users. There are not many users on this computer as of now. So just FYI, I'll go ahead and create a user here. And this user will be lusrmgr.msc. So that's a shortcut, lusrmgr.msc, to open the local users on this. In fact, on any Windows machine, you can run that command and it will open the local user console for you. I'll create a new user named Sam, and I will give it a password. And I can give an option like user must change the password at next logon, user cannot change the password, password never expires, or account is disabled. Okay, the password policy requirement is not met. I'm going to give it a more complicated password. Okay, so as you can see, this user is created here, and now I can go ahead and add the user here. I can say Sam, and one more time, I'll just remove this, and I want to show you, when you click on add, there are this pop-up is a universal pop-up which you are going to see throughout your life, and this pop-up has got some options here. So first of all, there is options like object types. What are you looking for? You can add groups here, you can add users here, you can add built-in security principles and other objects. We will talk about these things later. For now, you need to see that I have the user ticked here. So that's fine. And then the location. So currently, the only location possible for this computer is the local computer, and the name of this computer is Hyper-V. So that's what it is showing. So it's going to look up the users in this computer. And then I say, okay, I'm looking for the user Sam, and so I say check name. So it gave me the user Hyper-V / Sam. So like everybody has a full name. The full name of this user is kind of Hyper-V / Sam. So I chose that, and now I can say that either I can give Sam full control, or I can give Sam very restricted access, or I can say just read access to Sam, or maybe I can give some deny permissions to Sam. But you need to also understand that not giving any permission is pretty much equivalent to deny. There are very rare cases where you have to give explicit deny permission to anybody. In fact, try to avoid it because it creates a lot of issues in complicated environment. It is better not to give permissions rather than giving denying permissions. So you only allow the things which you want him to do, and you leave this thing blank in most of the cases, and this will keep your system and setup a bit more cleaner. So you give read permission to Sam. Anyways. Now this is a share, the data, this is the folder, it's empty. I'll just show you, I don't have any other computer right now in this network, so I can't show you from another computer. But what I'm going to do is that I'm going to access this same computer as I would access it from another machine. So if this had been another machine, what I would have been doing, I would go ahead and type the IP address. Once again, we are going to talk about IP address later, but I will just go ahead and write the name of this machine here, and from another machine, and I say okay, and it shows me the shares which are present on this machine. See, we are accessing it over network. This is called as //, the //. So // Hyper-V is going to show me all the shares which are available on this computer. And interestingly, you can see that I shared the same folder with two names, and it is coming with two different okay, I don't have permission to write in this folder. That's strange. And let's go here, and let's say, I say Shusher. So I created a folder here. I can see this folder here, and I can also see this folder here. This is just to show you that all three of them are the same folder. And interestingly, you saw that I was not able to create, or let me try to see delete. Okay, see, I don't have permissions when I access the same folder from the name Shusher. But when I try to do it from here, I do have the permission. And the reason for that is, if I go to the share level permissions, in a hurry to create two kind of shares, I did not give the appropriate permissions. So if I go to share, and if I go to permissions, everyone only has a read permission. So I give share everyone write permission as well. Click OK, click close, and let's see. Now if I go ahead and delete, I was able to delete. If I go ahead and create new folder, I was able to create this folder. Once again, you can see it here, and you can see it here. So the point is that that's how you create a share on a computer, and that's how you give it permissions, and that's how you access it. // If there had been another computer in this network, we would have been able to access the same thing from another machine as well. And yeah, that's it for now. I'm going to show you how to create these machines and how to create your virtualized environment soon. But until then, I hope you enjoyed this particular um, module, and I would like you to do your practice sessions. You can create all these shares on your own Windows computer, desktop, or any other folder path wherever you like to, and you can complete your action items. I'm going to Azure machine because I don't have a Windows machine, but for you, you can use your own Windows machine. Thank you. Thanks, guys, for watching this, and I will see you in the next module now.